Hello, this video is on integration and on the basic theory around what integration is and how it works. Integration is the other calculus function along with differentiation, which I covered in a previous video. Integration is also the opposite to differentiation, and it undoes what differentiation does, and vice versa. This means that you can use it to turn the gradient function, dy dx, into normal equation of the line y equals x. The notation for integration is this. You have this weird f sign, like that. Then you write whatever you're trying to integrate here. This is in the case of turning the gradient function into the normal function. And then what you're going to integrate by. So if it's a y equals 3x plus etc or something, in which case you're integrating in terms of x. That brings you into the equation y equals yada yada yada. So an example of this, if dy dx equals 1, the notation would be that. And your answer would be this, because if you differentiate y equals x, it goes to 1, and therefore if you integrate 1, it goes to y equals x. However, you also need to write that, because c is the constant of integration, and in this scenario, because whilst x differentiates to 1, x plus 1 also differentiates to 1, x plus 2, x plus 3, they all differentiate to 1, and therefore you need this, because when you integrate 1, it could be x, but then it will have some other part after it that you're not sure which this is. So it's important to always remember that. Integration can also be used to find the area under a curve. So what you can do is, if you have an equation, for example, y equals x, which drawn on the graph is like this. There we are. If you integrate that, so f that, you come out with half x squared plus c. And if you look at the area here, the x is there because y equals x, and that would be half x squared. However, the plus c is there, once again, as a constant of integration, due to the fact that you're not sure whether there would be another part to that equation or not. The reason you need this c is for anything that's an indefinite integral. However, if you have something called a definite integral, which would be, for example, the same integration as before, but like that. What this means is you're saying, I'd like to find the area between 2 and 1. So just this area here. And you don't need the c here, because by doing this, you'll get just a numerical answer. There won't be any x's in there at all. So once again, that will integrate to half x squared, but no c this time. And this has a notation like this, 2 and 1. And what this means is you do half 2 squared minus half 1 squared, which equals 2 minus a half equals 3 over 2. And that is the area between 2 and 1 of the equation under the line y equals x. So integration is useful for many things, and you'll also find in the future it can be used to find moments of inertia, and many other things. But this is the basics of integration, and yeah, that's how it works. It can be used to either reverse differentiation or to find area curves. Thank you for listening to the video. If you enjoyed it, then please subscribe.